Okay, welcome everyone to our chapter meeting for OWASP San Antonio. We've got exciting presentations today. We're going to be focusing on not only how we can use AI and defend against AI, but more how we use AI for positive reasons throughout the SDLC. So we're going to have, I think, 5 presenters today, including myself. So let's go to the next slide here. Oh, I actually have a controller. It's not working. There we go. So this is our agenda. I'm going to go over the the sponsors, the OWASP board. We'll talk a little bit about anybody looking for jobs in any companies that have positions after charter. These are the presentations we have lined up today. Then we'll for future meetings. If you'd like to get your input on that as we line up agendas for the future. We'll talk about membership. We're going to do some door prizes today for attendees. Certificates of attendance. We do certificates of attendance. They give the number of hours. Then we'll close out the meeting, and then we've got at 2:30 or around that, we'll break. We'll go to the patio, or you can stay in here if you'd like, and we're going to get drinks and just network, talk about best practices, whatever. There's going to be some tables out there if you want to find out more about their solution. These are some of our sponsors today. So please make sure you talk to our sponsors and kind of thank them for making this happen. Because without them, we'd probably be eating McDonald's, right? So this is our board. As you can see, we've got quite a few people on the board, and one of the things we do different from the other chapters is we have the in-person meeting, but we also have remote, right? So we're also doing this virtual. We have virtual right now, 40 or something like that are attending virtually. Yeah, around 40 people on virtual right now. So we want to extend the outreach that way, but it's a little bit more complicated. That's why you see all this equipment here. Okay, so is there anybody here that's looking for a position in cybersecurity? If so, stand up. We'll bring you a mic, and then once you receive the mic, you'll be able to kind of describe what you're looking for. Raise your hand.
Thank you.
All right. Thank you. Who is next? Okay. I think I saw someone over here. Yes.
All right. My name is Jack. I'm currently unemployed. I've never done anything like this, so I definitely feel like I'm jumping into the deep end. But I'm a senior at UTSA, studying computer science. I have a lot of interests.
Got a lot of echo going on there.
Regarding security and machine learning and natural language processing. So that's all I got.
Okay, great. Anybody else looking for cybersecurity position? Am I missing anybody? Okay. Any companies that have open positions? If you have an open position, sure. You bring him a mic. Yeah.
Hello, everybody. My name is Zachary Adams. All right, cool. No feedback. I am a senior information security analyst at Prospect. You okay? Good. All right, cool. So we do have one open position for a senior information security analyst. You should be able to find the posting on the Frost Careers website. But what we do is my team is the incident response team, but we also do detection engineering and facilitate some tests for the bank. And
Great. Any other companies looking to fill some positions? Going once, going twice. Oh, we got one there. Okay.
Companies in town. So if you ever want to send your resume to me, we will happily do everything we can do to help you find a position. So you can find me on LinkedIn. I'm very active. It's Lori White. Thank you.
Okay, great. Any other companies that have open positions? Going once, going twice. Okay. Not working. Yeah. Okay, so just a little bit about the OWASP San Antonio chapter in terms of our charter and the things we do. Then, of course, we're focused on best practices for guidelines, standards, tools for AppSec. We also focus on training and what's going on in the industry for training. Information on how to measure application security, and of course networking. So after this event, as I mentioned, we'll network. We'll be able to share our challenges, right, and get good information from one another. Okay, so what are we going to be talking about today? I'm going to be doing an initial presentation just to kind of set the stage for our other presenters. So when we think about AI, a lot of times when we talk about AI, it's, oh man, how are we going to get attacked next? And the bad guys are using AI to attack us. This is more focused, the theme on how we can leverage AI for AppSec productively for the different phases, right, of software development. What things can we do? What things are happening now? What things might be happening in the future? So my presentation is going to be more what if, right, to kind of get us thinking about those things. So let's explore the opportunities when we think about requirements identification, how we do a better job identifying requirements, use cases, misuse cases. How do we leverage AI to do that? Secure design practices. How do we make sure our design is secure? Maybe there's ways to use AI for threat modeling to automate a lot of that. Secure development practices, security testing, and production controls. So when we think about requirements, the requirements phase, a lot of times the security requirements just kind of, we miss them. When we go into design, we have to go back and address it, right, the non-functional requirements. So how can we leverage AI to do a better job of profiling the application, taking the functional requirements to help drive those non-functional security requirements, taking into account maybe the standards, internal and industry standards and regulatory standards that we're subject to bring that in, to do misuse cases for that as well, automatically using AI, right? So how do we leverage AI to do those things? So I did a little experiment on my own. I went to ChatGPT and I said, well, what if I enter an application profile, right? I've got a retail banking application that does checking, it does savings, it does retail loans. It's a regional bank versus a federal bank, so forth. And it said, what would be some security requirements that would apply for this? What would be use cases and misuse cases? And ChatGPT came back in like 30 seconds and gave me a pretty long list of things. So it was a great way to start because I've got my list of misuse cases. I got my list of possible controls that I would need to use, right? So then I use that to kind of formalize my security requirements going into the the design phase, where I'm going to focus on threat modeling, right? So if we're going in with requirements, we're going in with use cases and misuse cases, right, into the design phase. Again, we can use Gen AI and machine learning to identify threats, identify what the threat vectors are, come up with an actual threat model. We could feed the AI engine a base architecture and have it, based on the misuse cases, the use cases, the security requirements, actually generate that threat model for us. So I did that, and I says, well, if I'm just using ChatGPT, what it would do, came up with a stride model in around 2 minutes. Not even 2 minutes, probably 1 minute. I thought a little bit and came up with a stride model. It actually asked me what format I wanted in, gave me some options to format it and so forth. So there's potential. I'm not saying it's perfect right now. There's a lot of work that needs to be done. But at the rate that AI is advancing, it's not going to be long before we can maybe write a Python program to do a lot of this, go against a Gen AI API and kind of do a lot of this automatically to do the threat modeling, and then have a workflow where we interject, right? And then, of course, not only modeling, but then providing recommendations, right, for the risks that we find, right, in terms of remediation, right, so that we can fix the design right there and make sure the right controls are in place before we go into development, right? So what's the object? Go into code development with as secure a design as we can, right? So we get into code analysis, right? We're doing code scanning. We're identifying defects. We're identifying severities. So how might AI apply to that, right? Well, we've got pattern recognition, and we've got machine learning. So I know some of the vendors are doing this already, but if we look at severities, we get a lot of severities on vulnerabilities. They come in, and we have to kind of re-rate them because they don't take into account the compensating controls that we have. They don't take into account our risk appetite as an organization. They don't take into account a lot of things because it just doesn't know. So what if we had an AI learning agent that can bring those other considerations into the picture to give us more accurate severity determination, right? It's certainly a possible thing to do. So then what you're coming up with during development is more accurate severities. And then another thing is, of course, auto remediation, right? Auto remediation, auto testing for that phase. Why is it not? There it goes. So a lot of the same things apply for security testing, but more from maybe a system level, integration level, right? So we're identifying defects, we're identifying severities, we're recommending remediations, maybe doing auto remediation, and we're taking, we want to take our standards, our policies into account and leverage AI to do that as well. So again, I think pattern recognition and machine learning would really come into play here. And also be able to look at things like attack vectors and history of past incidents and bring that into play for misuse cases. And when we're doing acceptance testing during the acceptance phase, to say, here's the misuse cases we want to test against. So we're hopefully going into then using AI production with apps that are pretty secure. They meet our standards, they take our policies into account, they take our risk appetite into account, they take the functional and the non-functional requirements into account, but leveraging AI to help with that. So then we talk about production controls. How might we leverage AI for that? Can we move that window up a little? So this is where we get into machine learning and intelligent agents, right? Or agentic AI, right? So you've got these AI agents out there where we used to have RASP and so forth. You have these AI agents out there that are detecting, they're blocking, and maybe for certain things that we have clear policies for, doing some auto correction to at least shut things off to make things more secure as we look at it further. The WAFs, we have technologies out there that do it today, right? We have WAFs, we have these different things, but I think the AI can help take those things to the next level, right? And then if we think about looking across the SDLC, when we think about just orchestrating abstract across all those phases, posture management, right? And metrics and reporting, right? AI applications there as well. For example, for metrics and reporting, we can have intelligent agents that have both robotics process automation built in, but machine learning, putting those things together to not only generate metrics on what's happening right now, but to better forecast what might happen in the future if we don't do something, forecast trends. Another thing we can leverage machine learning to do is root cause analysis, right? We've got hundreds, maybe sometimes thousands of vulnerabilities we're dealing with. And a lot of times, a lot of those vulnerabilities are repeating over and over again, right? And we got so many things, we're not seeing that, right? We're not seeing that. AI can help us deal with that, to look at root cause analysis, say, is it a training issue? Is there a fundamental thing missing in our security requirements that we need to fix? Is there something in design where we're taking the wrong approach and that's why this keeps happening? Versus just continuing to fix the same vulnerabilities over and over again, right? Doing a better job at root cause analysis. So what are the takeaways? Again, the purpose of this presentation was not to give you answers. It was just to talk about possibilities for AI application throughout the SDLC, right? And as you can see, there's lots of possibilities. You can get on ChatGPT and some of these other AI tools and play with it yourself. And you can see there's some fundamental things there that can get better over time. So what we want to do here now is look at some presentations coming up next where we're actually doing that. We're leveraging AI to do some of these things. So with that, I'm going to introduce Sergi Alvarez. He's going to be online doing this presentation.
Software development in application security. And so what I'd really like to do is kind of frame this in terms of what we've seen in the evolution of software, where this fits in more in terms of what lessons we can take from the development of the abstractions we've used in the past, right? How we've moved through increasing layers of human usable tools that sit on top of machines. And so when I talk about that, what I really want to say is, how do we get back to understanding fundamentals of what's going on inside a computer and how that relates to the software that we write? So this is a cartoon from XKCD that I always like, kind of in how I position when I'm doing software development to my daughter. Right? What is a computer? It's this metal box, it turns on these lights, I type on the keys, it changes the lights, different things happen. So this is a tool that generates an outcome, but what's actually happening underneath the hood? How do we think of software development in terms of what the machine is actually doing? And to get that, you really need to drop down and think about what's happening on the hardware, right? We think about this in terms of outcomes that we want, tools that we use, deploying clusters in clouds. Like, these are very abstract concepts, but at the bottom, what you're doing is really just looking at these logic gates, very fundamental things. You have these bits in registers that are flipping on and off based on what you want the computer to achieve. So really, if you think about it, what is a modern computer? It's just billions and billions of on-off switches. It's little registers, it's little circuits that have a positive or negative charge, and that gives us the outcomes we're looking for. So when I think about what is a computer, that's really what I think about it as, right? It is billions and billions of little on-off switches that I toggle based on outcomes that I want to achieve. And so I always like to ground any conversation about the future of AppSec in looking at the past and how we've come from billions and billions of little switches to thinking about things like scalability, the cloud, CI systems, the things that we interact with every day that are so high and far removed from the underlying physical architecture. Because most of us never really interact with those bits, never really write any kind of assembly, generate code at that low level. You might meet a couple embedded engineers who swear assembly is a human readable language. I'd never touch it, right? You know, if I'm writing code, I'm writing in Python. I'm very far removed from what I'm doing. But we sit at this peak abstraction far above those physical bits, but ultimately this is where it comes to and what's generated as we come out. And you have to remember that there's this process of how we get from the abstractions that we use every day into those physical systems, right? Just a simple architecture of what a compiler looks like. Now, how do I go from source code? Well, actually, yeah, how do I go from source code, move down, and convert this into something that the machine is going to understand and be able to use? So I have this high-level code that I'm writing. I have this thing that I understand as a human, other users can look at and review and understand. But at the end of the day, what gets generated is bits, right? This is just a representation of what that actually looks like inside the machine. But ultimately, we're getting down the hardware and we're executing these things. And if you look at modern software development, right, we're only getting more abstract even as we right, there's layers of these languages that we're actually using in conjunction. So this is an example, a bit hard to read, but of a CI script that I wrote recently. And what it's doing is using Python code to generate YAML that's actually going to be run in a separate job. So I'm coming in, I'm writing code to write code that gets interpreted into a machine. Right, we have all these different stages within the development. I'm pulling in libraries that are in use that someone else has written. So all of these things come together to actually generate what gets executed. And so the way that I always think about software is until you actually have bits and registers, right? Little things going through the CPU, flipping on and off, executing instructions, all you have is an abstraction. And this is really the key point in the framework of how I like to look at and understand AI and what we need to consider as we come up with more holistic frameworks for how we secure AI and the code that it's generating, and how we use AI to achieve secure outcomes and in application security. Now, AI is the newest abstraction layer in software development. And if we look at the history of what that means for other abstractions that were developed in software development, it can give us an understanding of what we should be looking to both secure the areas around it and how we can use it also to help secure itself, right? If you think about development of any stage of abstraction in software, you develop the ability to accelerate and move faster, but it comes at a cost of there being some loss of visibility into the intermediate layers. But it also gives you the ability to use those tools to actually help secure themselves, right? The techniques of static analysis and compiler development can help with SAST, right? You can use a SaaS platform to help you secure more efficiently code that you've written that's serving as a SaaS, right? These things can be leveraged together to help secure themselves. And so when you think about that, it becomes kind of clear that what you need to do is understand how this interfaces with the other abstractions that you have and where you can insert humans into the mix. So it's always going to be an integration of humans and the AI working together and understanding where those trust boundaries live and how you can coordinate efforts to scale the abilities of the agentic AI, but actually make that a useful scalability for the people behind the scenes, right? How does this make your AppSec engineer's life easier? And so the one key thing, at least for the moment when we talk about AI generated software, is that it is at least generating software at the level we're used to as AppSec practitioners. Right, this is an example of a script that I wrote. I asked Cursor just to generate a quick Python script that would go and hit the IMDb APIs and tell me all of the movies that any two actors were in together. Just something I talk about the overlap of those, but it did it in about 30 seconds, wrote this script. But I can actually check and validate this, right? I can write Python, not very well, but well enough that I can read this, go through and actually see that this is doing what I wanted. It's using libraries I can validate separately. And that's kind of the point one, is that the emergence of agentic AI doesn't change the need for these AppSec fundamentals, right? Even when we were talking about use cases, potential ways that we can scale, that's how you're using these tools to achieve the fundamental aims that you're already working on. How do I scale out the ability to scan? How do I scale out code reviews? How do I actually leverage this to kind of have a broader impact in the things I already know I need to accomplish? But scaling is actually going to require the usage of AI. If you think about standard ratios, it's usually about 150 developers to one AppSec practitioner. If you've now accelerated the ability of developers to push out code, the question is how do you now scale out the capabilities of the AppSec team to be able to secure that? And that's the answer, is you need to leverage AI to expand out on those fundamental tasks. So part of that is actually just going to be using it again to accelerate development. Part of the practice of AppSec is going to be securing those code by integrating into the tools that you're using, scripting behaviors to achieve outcomes that you want, and just using this new abstraction layer to accelerate software development for defensive purposes. This is no different than, again, how we would scale out and use a SaaS service to secure another SaaS service, because it abstracts away some of the responsibilities, the management beneath the hood, to make us more efficient at achieving the outcomes that we want. So we need AI to check AI. And there's a lot of pending promises in that area. There are things like explainable AI. There are things like mechanistic interpretability, where we're looking at the models inside. That I do think will be important down the line, but really what we need to think about now is how do we use those in conjunction with isolated agents that have separate interests, shall we say, right? I don't want a consolidated tool that's checking its own work. How do I deploy multiple agents that can kind of validate each other and run against different scenarios without sharing a common representation under the hood? And so that is the separate question, is what about opacity? So we've said that an abstraction tends to increase productivity at the cost of increased opacity. It makes it harder to understand what's happening. So we can accelerate our fundamentals. We can leverage AI to keep up with the newer development that's happening, how we're scanning code, how we're remediating, how we're doing things like checks on PRs to make sure we're not introducing new security risks. But what do we do about actually understanding inside the AI? And so this was an interesting paper that I'd come across before. It was by Ken Thompson. It was 1984. And this is kind of not that obvious. I couldn't figure out what the best representation was, but it's how you would inject malicious code through a compiler so that when the code was compiled, it had this outcome. Checking the source code would never actually validate that this bug existed because it was done by the compiler. You would need to actually check within what the compiler is doing, what it's actually pulling, to validate that this would exist in the binary that was generated. And that's kind of the second portion of this, is again talking about the edges of abstractions, the areas where security lives. It's really about trust boundaries. So now I know that AI is sitting above my code. It's generating it. We're doing the validation. How do we figure out the areas that we need to secure around that? Because the truth is we're never going to have perfect insight into what's happening in the AI. Even again with those explainable AIs, with mechanistic interpretability as we're looking at what's happening there, we don't have a good understanding. And you can see work coming out from Anthropic, for example. They are analyzing what's happening in the AIs that they've generated using tools from biology, so trying to understand. And what we need to do is, alongside the actual deployment and scalability, is understand where we can apply trust and have faith that what's coming out here is something that we can rely on. We do that with our human practitioners now, right? We have development teams that we trust to deploy the things we're working on. You validate with the application security team, having those separate teams, but again, trusting that they're working in good faith efforts towards the goals of the organization. And so that's really it, is we need to be able to identify the trust and set those boundaries at the AI, knowing that we have reliable origins, reliable training data, not so much at the AI itself, but at those who are actually generating and creating these things. So I think that's how I've grounded a lot of my thoughts around AI. Certainly a lot of different directions to go with use cases, with specific examples, but I think that's what I wanted to take today, was just to present how do we actually think about this in the history of software development. What can we learn from other advancements, other abstraction layers that were created that accelerated development? And how can we understand the risk that's likely to present when put in that context? So, thank you. Yeah.
So if we're looking at AI as another abstraction layer,
Yep.
one of the things that, if you think about a software developer today, a lot of them are concerned about their jobs, right?
Yep.
So if we apply that, how do we see the roles changing? For example, today we have software developers, we have architects, we have kind of people that focus on requirements. Do those roles start to merge where they become more integrators and designers, and AI under the covers is doing a lot of the rudimentary work for them, right? So the roles might change.
I do think the roles will change, and you can see that a little bit again as software became easier to scale out quickly. You lost a lot, like you moved from waterfall, you moved to agile because you can quickly deploy and test things. And I think that's what you'll see with AI. Some of the need to go through these separate stages, they'll almost become blurred and consolidated, because your job is to define the business case the AI or the code should achieve. The AI will then go through each of the stages to do that, rather than you defining a business case, passing it to an architect to scope out. So I do think you'll see that, but there's no shrinking demand for software, right? There's no organization that doesn't have a massive backlog of things they want to do. So I still expect that scale to accelerate. But yeah, to your point, I think it becomes a different role in the same way that a modern web developer's role is very different than someone who's designing semiconductors on a chip, right? They're all part of the same stack, but what's needed for a business to achieve its outcome will look different in 5, 10 years. I just don't think it'll go away, though. It'll always be there.
Thank you. Other questions?
Yeah.
Yeah, I have a question. So, how quickly are you seeing this trend move? Kind of going off of that discussion,
Yep.
if this is happening right now, quickly, it's going to upset things, even if it is going to balance out later on. But if it is going at a reasonable pace and companies are slowly adding AI into their workflows, then it's not going to upset things too much. You feel like you're going very fast?
I think so. If you look at Cursor, the AI IDE, they scaled to a few $100 million because of the demand for that. And it changes things in almost an invisible way because, again, the outputs remain the same. It's a way that has enhanced developers' ability to generate code, but you don't necessarily see that if you're sitting at a business level defining requirements and then seeing what's pushed to production. Right? You don't realize how much this has been outsourced. And you can see other cases where people will start to just pull in and deploy tools because developers are going to find efficiencies unless they're explicitly told not to do something. So that's the other thing is scanning and looking at applications. We're seeing a huge number of APIs calls to third-party models or deployments simply because they weren't told they can't do it and it was an effective way to achieve it. So I think it is already happening. It's that the change will be slower. What you're going to see first is the acceleration. And second, you're going to see, okay, now we need to figure out how to contain this. So it's kind of a pendulum swing where it goes to adoption, scalability, speed, and then how do we start to corral this more efficiently?
Yeah, that makes sense. So it also sounds like the developers are wanting this as well. And they're bringing all these tools because they're seeing the benefit of it as opposed to something that's going to be pushed on developers, but they're apprehensive about it. It's not bad. They really want it.
No, I think I've seen, a lot of interest from devs. I think there is and will be fear when any profession changes that this will change what my spot is. And, there's concern that I maybe can't scale or maybe something becomes redundant. But the reality is I think it does just accelerate what developers can achieve and they see that benefit. One of the really good explanations that I've seen and what I found is it's just so good at getting through all of the boilerplate code that needs to be written. That's kind of takes an effort lift to do first. So like all of the scripts that I showed, I used with AI. I tweak them and rewrite some stuff. But it's so much easier to start from a baseline that accomplishes most of it, and then I need to adjust, than to sit down and research what tools I'll even need and start typing that first line of code. So I think that's really it. Is right now there's excitement's always tinged with worry, but that's kind of where we are is at that point of acceleration.
Yeah, sounds good. Thank you.
Yeah, thank you.
Can you see my screen? Yes.
Ready to go.
Okay, so let me start. Okay, I will start. My presentation is about leveraging AI for vulnerability identification. The idea is to find out, understand the limitations and the advantages that we can get using AI to analyze mobile applications. To basically find out which vulnerabilities there are, which recommendations we can get for developers, but not just from the source code point of view, but mainly focus on the binary analysis. So who am I? I'm a mobile security research engineer at NowSecure. I mainly focus on iOS, but sometimes I also do stuff for Android. My real name is Sergi Alvarez, but most people in the internet knows me as Pancake. You can find out my Mastodon handle at the bottom of the slide if you want to follow me. I'm from Barcelona, and that's the main reason why I'm doing that presentation online. And I'm also the author of Radare, which is a static analysis tool. It's mainly focused on scripting and command line usage. And it's able to analyze many different kind of binaries, not just mobile applications, but also malware, Windows, macOS, Linux binaries, and also IoT. I'm a free software hacker. I've been developing tools in the open for so many years, and I try to do as much things as possible as free software. So seems like a few years ago, like a couple of years ago, there was like a boom on AI. So a lot of aspects in our life has been changing, and mainly on the companies and all the products and the software we use every day have been integrating AI in different ways. And obviously, this is also affecting us in the mobile app ecosystem. So it's affecting in the development. There is more developers being able to develop more applications or introduce more changes in the applications. Sometimes this is good. This can be also bad if the developers don't know what they are doing. So we can say that it's also reducing the developer effort to introduce updates on all the applications that everyone is having in their pocket. Also, it's changing the security assessments, the way that we analyze applications, the way that we get coding recommendations for our customers or the use cases that we have when developing applications, and also for testing. It's very easy to ask an AI to write a test suite for a specific part of the application and create unit tests for all the functions in a library, for example. And also is helping us changing the way that we do reverse engineering, because it's reducing a lot of tedious tasks that we can automate now in a very easy way, just asking the prompt how to do something, and the AI will do the hard work for us. And also giving us a plan for how to, which kind of things should we addressing, or which things should be checking out, and getting some feedback. Sometimes it's easier to ask AI than trying to ask other people in the field to get some feedback. So it's changing so many things in the technical point. So as we can understand, there is so many security implications in all this. We don't know if we can really trust the language models. There are so many different models. There is so many different prompts applications. Also, some of them are running in local, some of them are remote. Some of them are actually integrated agents that are leaking data or are executing code without our consent. Also, language models can hallucinate the response. They can say something that looks like real, but it's actually false. So we need to actually understand and always have someone that knows or understands the problem to analyze the response from the language model. From experience, I will say that AI is helping in many things, but we always need to have a look at what we get from them. Also, we cannot ensure that the code quality that the language models is responding is the best one that we can get. And also, it depends a lot on the language that we're using. So, for example, asking an AI to modify or write TypeScript is much easier and better than asking an AI to write assembly or C. And this also depends on the operating system and the framework that we depend. So, for example, in frameworks, there is a lot of issues because they used to be versioned and they changed the APIs, and we can ask the language model to write some code for a specific version of the library, and they can be confused and write code for the wrong one. And also, it will be reducing the security risk, but maybe it will be increasing that. So we need to understand these security problems and try to find the best approach depending on the needs that we have. On the focus for reverse engineering use cases, I will say that there is so many things that we can do with that. We can improve the compilation listing. So, for example, we can get the disassembly. And out of this assembly, there is different compilers that can convert this disassembly into pseudocode or high-level language like C, for example. And then throwing this code to the language model, ask them to write in a different language, for example, or just rename variables, arguments to make it something more explainable. And we can also to name the methods, the symbol, hyperpropagation, the functions, and do so many things that we can do by hand, but in an automated way. Obviously, this takes time and money, because if we are using local models, we need proper hardware to run all this. And by proper hardware, I mean like 64 gigabytes of RAM, a couple of graphical cards and things like this. And with remote, we have to pay for a service that we can upload that, and with all the risk that we are leaking data to them. And also we can integrate that with other tools and get information from different sources, like maybe documentation recommendations, like AMSTG from the OWASP security guidelines. And also we can ask the models to explain a function, explain or find vulnerabilities in the code. I will be showing that later in the presentation. As I said, we can query documentation, we can find vulnerabilities, we can also ask the model to get bad coding examples, like for example, tell me which is the wrong way to write maybe a SQL statement, or how to, what are, not just asking how to do things, but we can also ask the model to get good and bad examples, which is something that the OWASP guidelines are giving to us. Mainly because this is all the OWASP guidelines are open source. All the public language models are trained with this data. So it helps us a lot to have a quick understanding of many of these issues that we can find in modern applications, and get varieties in different programming languages, like maybe Java, Kotlin, Swift, etc. And all this information can help the analyst to spot more findings and spot more vulnerabilities in their applications. Because this is guiding the analyst to find out which is the next thing that they should be looking for. And as long as this is a manual process, we can automate and speed up the process, and also remove all the tedious part and focus on what matters and the stuff that the humans can do, that the AI can do right yet. So I will be introducing R2AI now. R2, as I said, is the reverse engineering framework that I started developing 18 years ago. It's mainly focused on the command line usage, and this is helping me to integrate and extend the tool in a very many ways. Because as long as it's focused on scripting, we can write plugins, we can extend with different tools and integrate with other applications. There is R2AI, which is a plugin that consists on extending R2 with AI capabilities. And this repository contains different implementations. The first one is a plugin that is written in C and it's loaded inside R2. So you can basically get all the data you have inside the shell and send that to any language model you like, from local to remote services. Also, we have the Python implementation, which was the first one that I started writing 3 years ago. And this implementation, it's have a REPL. You can make questions, you can chat with the binary and get the output from the R2 processed by the language model. Then we have Decay, which is the compiler based on AI. And this is a JavaScript plugin. It's very simple. It's very easy to understand if you want to contribute. And there is different features for improving the disassembly and get all the decompilation in the language that we like. So for example, we can get Swift decompilation, or maybe we're interested in analyzing a Flutter application, and RTK is able to extract all the information that needs to get the compilation understandable by the analyst. And finally, we have R2MCP. MCP, if you don't know what's that about, it's the Model Context Protocol. It's a protocol that was invented by Anthropic Cloud. And it's basically a kind of like the inetd daemons in the Unix side, but for AI. You have different tools that are running, communicating using standard input and standard output, sending JSON objects to expose methods. And these methods can be used by the AI at will. So, for example, if you ask the language model to analyze a binary, the MCP will be exposing the methods for analyzing, listing functions, getting the compilation of a function, getting strings, things like that. So if you start the R2 MCP with Anthropic Cloud, for example, you can just ask the Anthropic Cloud to analyze a binary, and you will get all the automated process for you. If you want to install any of these, just run these commands. R2PM is the package manager for R2. So -CI is for clean install, and then the package name. And as I said before, there is different providers. If you want to run this in local, you can use Llama. You can also use Llama CPP or OpenWebUI. OpenWebUI is also exposing OpenAI endpoints. So the same protocol that is used by OpenAI and many other language models and services, you can use the same communication using curl or HTTP in local. And for remote, you can basically use any of the companies that are providing these language models endpoints like Mistral, Gemini, Anthropic, OpenAI, XAI, Grok, etc. So the thing is that there are so many different models, there is so many different providers, and all of them are integrated with R2. But the thing is that there is so many prompts that you can use. Also, the embedding of the context can help to reduce hallucinations, but still we should be testing them all in order to understand which is the best one for our needs. So this is a quick sample. It's a sample application that I wrote in Swift for iOS. It's an application that shows a password, and when you type it, it's telling you if the password is okay or not. In this case, if the password you type is password123, you get a success message, but otherwise you will get an error message. You can see the output from Ghidra in the right side. You can see that the compilation is kind of complex to read. There is so many mangled names and also some boilerplate of bridged object release methods. And also one of the things that Swift and actually Rust and all the modern optimizations written by Silang is that the strings generated by the compiler are not in line in the binary. They are inside the assembly. So they are basically constructing the strings as immediates in registers, and they are passing the register types as argument to the methods instead of passing the pointer to the string or the pointer to the data when it is pointing to the ASTM object. And as you can see, Ghidra, for example, in that case, is showing the password in the reverse way. So that's not correct. So if we use R2 using the pseudocode and we throw that through the KI, and we can ask the KI to decompile using Swift, and we'll end up having actually the same code that was originally in the source code. It's actually not the same, but the behavior is the same. You can see that. Another cool thing is that we can ask the model to translate that to the language that we like, because language models not just understand human language, but they also understand programming languages. So we can ask the model to translate the Swift code into Python, or maybe we want to use Scheme or Kotlin or the language that we like, maybe Bash scripting, whatever. So let's see what else can we do with the KI and R2AI to identify vulnerabilities. We need to understand that the application security guidelines require times and experience. So everyone that's starting in the mobile security analyst field, they need to test, to reverse engineer so many applications, learn a lot of documentation, maybe watch presentations and write tools for testing all the data they are learning. But the cool thing is that AI knows most of this, and we can use AI as a way for learning. And there is so many models out there that are trained with the MSTG guidelines, also with CVEs, document databases, and malware samples, and many blog posts that are analyzing different binaries, as well as all the CWEs and so on. So I will encourage everyone to use AI for learning because you can also use that in local, but you should be always testing that the information that you are having from there is correct. But even if it's not correct, it's also helpful because it gives you ideas to check more things and verify that you are is correct or not. And finally, I will say that there is different ways to ask the same thing. So as long as language models work with human language, you should be asking the model in the proper way what you want to get from there. And one of the cool things of MCP as well as R2AI is that they too have the auto mode. Auto mode is not just making a question and getting an answer. It's about making a question, and then the language models will understand all the steps that needs to be done before getting at the answer. And each of these steps will be basically running tools in your local machine or in remote machines if you are running this in the cloud. So it will be able, the language model, to execute methods in your MCP server in local, open the binary, analyze it with your tool, getting the strings, analyze the methods, the compile stuff, and get all the steps until it's done. So this can be really helpful for finding hard-coded passwords, encryption keys, identifying scripting code injections, and so many other stuff that we can, as analysts, we used to get by analyzing that by hand. Yeah, we are reaching the end of the presentation. I'm going to make a demo. As you can see, there is this Comic Sans message at the bottom of the slide. This is actually the prompt I used with Claude to get a report. I'm asking Claude to open this DeepSeek binary using. This is the main executable from iOS. I tell them that I want to follow the mobile application security testing guide and get a quick analysis to properly generate a report and find out which are the most relevant security findings and get some recommendations for that. So I will jump into the Claude thing, and this takes like 10 minutes. So as long as I don't have 10 minutes, I will just show the final report. Can you see that? Size. So the first thing that Claude is responding is explaining that what we'll be doing. It will be running rather to using the guidelines, and then it's showing me which methods is used. As you can see, we get the output from R2. We can get the output from the headers of the binary. Then we get the list of the libraries that the application is linking to. And then it's checking for the sections, the list of entry points. So this is basically all the main built-in load methods and all the methods that are entry points for threads and the main execution. Oh, we can also get all the imports. We get the analysis, it's starting to do different analysis. So it's finding almost 50,000 functions and then starting to find out which of them are the most interesting. Then it's checking for all the strings, grabbing for some specific keywords, then goes for other keywords, and so on. So as you can see, these methods are exposed by R2. So this is the R2 MCP. It's able to analyze, close file, the compile function, disassemble, get current address, list all the strings, list classes, etc. And then start with all this information then it's processing the data and then generating the final report, which is what we can read here in the right side of the screen. So it was able to identify the name of the application, which is the target architecture, the compiler that was used, the language, and then it's showing different information, like for example, the network communication, how it's working, which are the main endpoints, the upload endpoints. Also the data storage and protection. It's trying to find like hard-coded API keys, user privacy links, and then third-party libraries, and then explaining which are the best security recommendations if there is like, for example, security risk that it found, low risk, and then some recommendations for that. We can prompt the language model in a very different way and get completely different results. And also we can run the different types of analysis. We can also expose more details to the application. So as you can see, this report took like 10 minutes to work, to generate. And it's quite complete, but it's far from what we can get if we know what we're doing. But the thing is that this is very useful for us because as an analyst and someone that is learning from the security point of view, we can get a lot of details in a very quick way, and then we need to verify each of these findings because some of them are false, some of them are true, but we need to understand how to extract them and process them. Yeah, that's it. That was my presentation. Thanks for watching. Any questions there?
Have questions for Pancake? Questions for Pancake? Got one over here. Wait for the mic. It's coming.
Hi. Yeah, so thanks for the live demo. It seems like this would be really helpful for analysis, like in a mobile assessment, let's say, even if you have source code, being able to show just from the binary, you can understand certain logic and then go to an exploit. Do you think this would ever be a tool that could be part of the MobSF framework?
Yeah, actually, the Kai and R2 have been used in the OWASP security guidelines. There is some examples about finding vulnerabilities with using R2, and also getting the compilation out of that using AI. But I think it would be great if we can start testing out all these kind of things, but mainly focus on local models, mainly for privacy reasons, but also for stability. Because, as I said, the context that you provide to the language model will make the output quite different, and we need to verify that the output is always the same. So one of the things that the Kai is doing is changing the temperature and many other configurations of the language model to make it as deterministic as possible. This means that for a same question, we will always get the same response. But this is always subject to the language model that is running in the website and other parameters that if we are not in control of that. But yeah, I think it would be really cool if we can start integrating that in the guidelines.
Yeah, thank you.
Other questions? Okay, I think we're good. Thank you very much, Pancake.
You're welcome. Thanks.
If you want more information on Pancake's presentation, we do have representatives of Now Secure here today that you can network with them later, and he can send you more information. Okay. All right, our next presentation, we've got Rob Dickinson from Graylog, and he's going to talk about non-human identities and how we use AI. So Rob, welcome.
Thank you. Yeah, that's the advanced there. Thank you. All right. So AI and non-human identities, or NHI. So I'm pretty sure everyone's heard of AI. Every talk has mentioned it. Who here has heard of NHIs? Anybody? A couple of hands. So NHI is non-human identities. It's a new classification that OWASP has. There is a top 10 for NHIs. So put that on your reading list for later if you haven't seen this yet. I'll be giving kind of a brief overview of this, but there's a lot more information about NHIs. And this is one of the big things that OWASP is doing this year. So very much worth checking out. I'm Rob Dickinson. I'm from Graylog. We're a security company. You may not have heard of us yet, but that's why we're here today. And we'll be out on the demo pad out here later. All right. I'm also easy to find online. If you have questions after the talk or just want to connect, I talk about APIs and security all day. So yeah. I'd love to contact you. All right, so we talked a little bit about agentic AI. That term's been thrown around here a few times. Let's break down, though, what we mean by AI agents. When we're talking about AI agents, what do we mean by that? We mean that these are autonomous programs, right? They're typically adapted to a specific domain, a specific problem set. You have an agent. A lot of the early ones that we saw around these were things like recommendations. Things that you can adapt to a specific task. You know what the task is supposed to be. You know what domain it's supposed to be in, and it has a fairly narrow sphere of influence. So we're not talking about generalized AI here. We're talking about AI that is adapted to a specific process or a specific business purpose. These AI agents are also capable of solving problems. You can ask them to do things, and they'll give you back a response. They can, to a certain extent, they can understand what it is that you're asking and try to map that to the information that they have, again, within that fairly narrow domain. This is probably an obvious statement, right? That AIs are backed by an LLM, backed by an AI. That part is fairly self-evident. The part that isn't necessarily self-evident And as a software developer myself, that's maybe the hardest bit here to actually wrap my head around, because I'm really used to having software that will give me the same answer every time. If I give it an input, it gives me the same output back. If my QA team goes and gives the same output or same input, they'll get the same output back. I'll get the same output next year that I would get today, right? LLMs are not necessarily that deterministic. You can give them the same input multiple times. They can give you different answers each of those times. They can also drift over time. They can give you different answers next week or next month than you would have gotten today. That's part of what makes these cool, right? Because we can use them to solve problems that aren't necessarily purely deterministic. But we have to acknowledge that these things are somewhat unpredictable in nature. And there's really, and that ends up being what everything else about here is what we're going to be talking about, right? Because these things are somewhat unpredictable. How do we make sure that they're staying in a safe boundary? How do we make sure they're not doing things we don't want them to do? That's the real challenge here from a security perspective. Now, where NHIs or non-human identities have entered the chat is when we think about, well, how are these AI agents identifying themselves in terms of using these other systems and these other resources that are out there, right? Every security model that we have traditionally is tied back to a user account where that user account has rights and privileges attached to it. But in this case, there is no actual user. There is no human that's attached to this, right? So that's where this idea of non-human identities comes into this, that we're going to have traditional human users that we identify with those user accounts, but then we're going to have this growing set of AI agents that are not actually backed by people at all. And now we have to treat them from a security perspective as this new class of entity that we're tracking in our systems. So what are NHIs? So for people who haven't seen this yet, NHIs are the mechanisms that are used to authenticate these AI agents. And I think it's easier to use some specific examples to talk about what those are. And you'll see these are fairly traditional concepts, but NHIs is kind of the new moniker that's put on top. So service accounts may be one of the first things. Another example of that would be cloud resource roles. So you have roles that are established through your cloud provider, granting access, granting privileges to those roles. And then the AI agents are basically using that as the mechanism to access protected resources in the cloud. API keys are another example of that. In a lot of cases, API keys are for external consumers of those systems. So again, these AI agents can be anywhere. They don't have to be your AI agents. They can be other folks' AI agents that are external to your organization. We also see things like third-party certificates used for allowing these NHIs to access these protected resources. So again, NHI sounds like it's completely new. But really it's an umbrella term that wraps a lot of these fairly traditional concepts. And again, you should definitely check out the top 10 list to some of those pieces in the top 10. But the core takeaway here is that from a security perspective, from a governance perspective, we really need to be thinking about securing these AI agents the same way and with the same verve as we would to secure our actual human actors. Okay, so let me try to give you a visual picture of what this looks like. So in a lot of cases, the traditional pattern that you'll see for an AI agent is you'll have an agent that you can identify. It's adapted to a specific domain. It's intended to do a specific purpose. it has an API that is the way that you talk to the agent, because the agent is a machine. So we need a to talk to the AI agent. This is an LLM, right? So the LLM is essentially the knowledge, if you will, that the agent is using to make it. And the API at the front is how you talk to it. Okay, simple picture, right? And then the way that you consume this is you're going to have an application or a script. That application is going to talk to the API in order for the agent to do some work, and the agent's going to hand back a response to the application or to the script. In most cases, we're talking about web protocols here, so this would be HTTP or HTTPS, and this is as technical as this gets in this talk, right? No other acronyms here that you have to write down or remember. And this is a pretty simple picture. This is pretty much where everybody starts when they start thinking about these AI agents, and they start thinking about how they're going to use them. ChatGPT being maybe the most canonical example of this, right? The application in that case is your little chat window, and you're talking to the OpenAI, OpenAI API. That model is giving you back. That's pretty simple, right? Does anybody think it's this simple for very long? No, of course not. So this is where the security aspects really start to take on a life of their own. Because what's going to happen next is once you start falling in love with this pattern, you're going to start to get tremendous fan out, just like you do with APIs. So it's really easy for me to create an application or a script that talks to one agent. It's just as easy to create an application or a script that talks to multiple agents. So we've got this immediate notion now of fan out, right? Because these are just remote calls. I can make a remote call over there. I can make a remote call over there. I can use 2 agents. I can use 10 agents. I can use 100 agents as easily as I can use 1, because it's all the same plumbing, right? So from a security practitioner point of view, this should start to make you feel a little bit nervous. Is there a boundary to that? How many of these things could I be talking to at once? Yes, it's unbounded, right? So the fan out here, the complexity here, starts to run away from you very quickly.
Also from a system resource too, right? How heavy is the agent? Resources do they consume if they each have their own LLM?
Yes, yes, absolutely. Oh, sorry, I'll hold it up more. Yes, the system resource and governance is a huge aspect of this, right? The other thing that you can count on happening is these agents are talking to each other, right? Because when you talk about the process of building an AI agent, it's just like building any other kind of piece of software. And what do you do when you start building software? Well, you see what other building blocks there are around there that you might be able to pull together to solve the problem that you're trying to solve. So these AI agents can talk to each other. You can have agents talk to other agents in order to fulfill that original request. And it fans out from there, right? Now you start to have a supply chain of AI agents that all have to talk to each other to fulfill a very simple request from the application or script at the outset, right? And here's the thing, when you're talking to just here, you don't necessarily know what's behind that, right? That's what makes it a supply chain issue. The same way that you had the same issues with APIs in general and distributed systems in general. This is just the same problem now, but we've got these much heavier weight components. We've got these, in a lot of cases, these massive LLMs, right, that are being wrapped up together and strung together. These could also come from different vendors, from different providers. They could run on different clouds. They could run on different areas of the world, right? And we've seen that with supply chains and supply chain attacks in general. We can expect AI agent supply chain attacks in the future for the very same reasons. So hopefully, as you know, since everyone in here is interested in security, you should start to feel a little bit of discomfort at this point, realizing what the potential is here for abuse of these kinds of systems. Because every path that we have here, every time we're making a remote call to yet another system, is an opportunity for that system to leak information that it shouldn't leak. It's an opportunity for it to fail, for it to do something that's unintended, or just hallucinate and hand back something that the rest of the system isn't going to be able to process, right? And again, this mirrors a lot of the issues that we see with API security in general. The only way truly to combat this kind of fan out is to have feedback and validation points essentially on every path within that chain. So the only way to know that these agents are actually doing what they're supposed to be doing is you have to watch what they're doing, right? Because they're somewhat unpredictable. I'm not saying you shouldn't test them, but what we are saying is once these things go out into production, you can't assume that they're going to do the same thing that they did during the development cycle. They may be doing things that are literally harmful, and you have to be able to find those specific cases in order to adapt to those cases. Now, I know, everyone in this room is a security practitioner. Most of us have been doing this for a long time. And I'm not going to go through the list of all the things that we do to secure systems for humans because the folks in this room already know those, right? Security for humans is, in some ways, much simpler than what we're talking about here. I can take a human, I can make them do required training, I can make them sign a piece of paper about what they're allowed to do and what they're not allowed to do. Don't take internal company data and send it up to OpenAI. Right? We can have a company policy that prevents doing that. These AIs are not really trainable in that same way, right? We need different mechanisms to govern what these AI agents are doing than the approaches that we've taken to govern the humans that in a lot of cases these AI agents are replacing or supplementing. And this is really where the work that OWASP is doing now around NHI really comes into to full force. And these are some of the things that you're going to see if you go and look at the OWASP top 10 for NHIs. So one of the first things that we have to embrace with these agents is proper onboarding and offboarding, right? So you're going to need a process to bring new agents online and make sure that they get the proper access that they're supposed to have. If you're doing this in a healthy way, you also need a process for offboarding those agents and keeping track of what their time to live is supposed to be. I think we've all either seen or heard stories that go something like this. We hired a contractor, they did a bunch of work for us, the contractor's gone now, but I can't actually deactivate that contractor's account because every time I do, there's stuff that breaks on the back end, right? So I'm just going to kind of live with that security hole that I have. You get the same kind of thing with AIs and these AI agents. So proper offboarding, proper review. How many agents do we actually have? Making that a countable number and having an actual time to live is critically important. It's probably obvious that you also want to limit the scope and limit the privileges of these AI agents. Principle of least access certainly applies to AI systems the same way that it applies to humans. Avoiding excessive reuse, I think, is one that's very specific to AI agents, less specific to people. So the idea here is that You know, especially as software developers love to write things that are general purpose, right? Better software is more easily adaptable. It can do more things, right? There's the old joke that, you know, the best word processor in the world, you should be able to set one flag and it becomes a spreadsheet, right? So this idea that you create an AI agent, but you don't want to empower that over broadly. You want to limit what it's supposed to do. And part of that is being very careful about when you're going to be reusing that agent for to do other things, right? Because every time there's that opportunity for reuse, now you're expanding the privileges that AI agent is going to have, and that in itself is going to invite security issues. Isolating environments is another thing with NHIs and AIs in general. The software development lifecycle, you have a development environment, you have a staging environment or a testing environment, you have a runtime environment, right? You have to keep those environments separate, and you have to keep your AI agents and the non-human identities that they rely upon separate between those environments, right? You can't be developing in production. It's a bad idea. I mean, yes, you can do it. It's always a bad idea. So this idea of isolating your environments is very, very important. And this is an easy mistake to make, right? When you do a deployment, in a lot of cases, the environment that you're deploying to is a parameter, right? So you're only one parameter mistake away from deploying this agent to the wrong environment, right? That is a very, very important risk to be aware of. Prompt engineering, of course. The extent to which you need to govern what kinds of requests the AI agent are capable or allowed. And we've all seen cases where this goes wrong. And the worst cases that I've seen are cases where this actually leads directly to data leakage. So one story, I won't share the names of the guilty here to protect them, but one of the cases that we've seen about this was an AI agent that was deployed to help with HR questions, things like benefits, things like promotions, things like who does this person report to, right? Basic HR functions. This particular client that we had, they put up this agent, and within a few weeks, someone had tricked the agent into leaking all of the salary information about everyone in the company. And that was not something that they wanted to do. It was something that the AI agent had access to, and in some cases that was intentional, right? We want this AI agent to help with budgeting, so it needs to know where the money is going, right? But if you can trick it into telling you what everyone is making at the company, that's bad. And unfortunately, the AI doesn't really understand the difference between those two kinds of data. So going back to the diagram that we had before, what we see as the most common security gap around AI agents specifically, but also around API-driven systems in general, is a lack of runtime validation and runtime monitoring of what these systems are actually doing. So the fact that they're unpredictable, the fact that they're complex, the fact that there's a whole supply chain involved in all this stuff, you can have secure practices out the wazoo to secure your development process. But if you're not actually monitoring what's happening at runtime, you might be one configuration issue away from the system working properly. And we see that kind of stuff all the time. So how do we do that? Runtime monitoring traditionally involves collecting a lot of data. So a lot of the things that you'll hear about this are things like, well, that's going to be difficult. There's a lot of data involved. There's a lot of API calls that are flowing around. That's not easy to do, right? That's difficult to do, and it is difficult to do. So you really need to be looking for a monitoring stack
that really understands and is built for these kinds of challenges. And what it starts with is it starts with all the logs that you already had. So the application logs, the cloud provider logs, the logs out of your firewalls, all the other infrastructure logs that you have, your application logs, all of that is going to be telemetry that helps you understand whether or not these systems are actually doing the right thing in production. That is not on its own sufficient, though. What these bottom three boxes tell you about is what the infrastructure is doing. You have to actually monitor the API requests and responses. You have to monitor the usage of those systems to actually get the full picture. Without monitoring the API requests and responses themselves, what you'll hear folks say is they'll say things like, well, I know we've got these API endpoints. We know they're live. We know we can see network traffic that's flowing back and forth to those endpoints. But we don't really know, is that good traffic? Is that bad traffic? Is their data being exfiltrated through those APIs? We don't really know. So the network monitoring and the traditional infrastructure logging that you have is typically not sufficient in order to actually monitor the activity. And again, if you think about it, the activity is the part that's unpredictable. That's the part that the AI agent is trying to solve for you. So just having logging about the infrastructure of the AI agent and knowing that the AI agent is up and available and responding quickly is really not enough to understand, is that agent doing the right thing? What you want to do then is you want to take all these sources of data. So you want to take your traditional logs, you want to take your activity log about what your APIs are doing, and you want to bring that into your SIM. You want to bring this into your normal security workflow, right? One of the other kind of anti-patterns that we see a lot is we see folks that talk about like API security in a vacuum. Like API security is this brand new thing. It's a new discipline. It needs new tooling. It needs new workflows. It needs new processes. No, it doesn't. No, it doesn't. API security should be part of your existing security infrastructure, your existing security processes. It should fit into your existing workflows. And ideally, it fits within the SIM and the other tooling that you already have. Instead of thinking about this as kind of a discipline unto itself, what we're really just talking about is we're talking about monitoring the activity of these AI agents and bringing that into our SIM. When we bring that into our SIM, now we can do all the things that we would normally do as far as securing our digital systems. We can look for correlations between events. We can track our assets. Our AI agents are becoming a new kind of asset, right, for the organization to track. We, as Graylog, we even think about tracking our attackers as assets, because they are. They show up. They consume resources, right? We want to know what they're doing. Those are all assets that are meaningful for the organization to be tracking. We want to have strong investigation workflows. We want to have things like AI summarization that help point us towards the signals that we should be paying attention to. And then, of course, we want to bring this into top-level dashboarding, top-level reports. We want to have KPIs that we can track, just like we do with everything else. So again, it's that idea that API security and even security for agentic AI need not be a separate discipline, right? At the end of the day, we want to bring this all up to high-level KPIs that the business can track, just like everything else that we do. New technology, right? New ways of using these LLMs, but the way that they should plug into how we think about security and how we organize our security practices, it should feel very comfortable. And that is my presentation. Thank you.
Questions? Very interesting questions.
Bring a mic over. Tell us mic.
Thank you for the presentation. So you talk about onboarding about the agent. So where should their ID stay? So, you know, for service account, I know they can stay in the Active Directory or stuff that, but I kind of struggle about the, you know, where should the ID of the agent stay? Thank you.
Yeah, I don't know that there's one like crisp canonical answer. I mean, I think the best answer would be who was managing it before, right? The responsibility there ultimately falls to the security organization, I think, to secure against AI agents and outside attackers. The same way that you'd be monitoring the security of any managed asset, right? The challenge, though, is actually getting that information back to the security team. Because a lot of the cases that we see, the developers are doing this on their own. You know, the developers have a task that they're supposed to do, and so they develop an AI agent to do that, and they don't really tell anybody that that's now running on the network, right? So that process of discovering even what new agents have been set up can be a real challenge. Even for companies that say they practice a pretty tight change control model, these AI agents can really fall through the cracks, right? I don't have to provision a new user for it. I can just put it out there on the network, right? So really, like your security organization, and whoever is auditing those assets, this is a critical piece of information that they have. And for a lot of the cases where we're talking about onboarding, it's not necessarily onboarding in terms of creating the agent. The onboarding is really making sure that everyone in the organization needs to know about that agent, knows about it, and that proper practices are being applied to it, versus it's something that development did in secret and security may discover it, you know, months from now. Yeah, nothing wrong with the spreadsheet.
Well, thank you.
Thank you.
Early, do we have more questions? Do we have more questions? There's one.
So, do you imagine like new training architectures or fine-tuning architectures that kind of optimize this whole like agent pipeline, like to prevent things like prompt injections where people are getting data that they're not supposed to? You get the API response and then you label that as like bad, and then you fine-tune from there. Is that like a direction?
Yes. Yeah, and yeah, so it's really the feedback loop there is really the important part, right? Because just like in any kind of development or any kind of testing, your QA team tests things, your development team tests things, your customer acceptance people are testing things, but all that you know is what's been tested. Then you put these things out into the real world and you get all these other behaviors that you didn't expect, right? The number one reaction that we hear in terms of runtime monitoring is, I didn't know my users would do that. I didn't know my attackers would do that. I didn't know my systems would do that, right? So even though we're talking about agentic AI and LLMs and all these other things, it's still security. And security in a lot of cases is a failure of imagination, right? It's a failure to predict or anticipate things. And we all do that. We all end up in our comfortable little bubbles, right? But as soon as these systems are out there in the wild, there's all kinds of things that are going to happen. And that's what we see in the news all the time, right? I think to your question, I think we also will see more sophisticated pipelines around building these. When you think about, we used to build software by hand, now we use CI/CD pipelines, right? I think we're going to see the same thing here. A lot of the agent development that we're doing now is kind of by hand, and over time we will see more robust and purpose-built platforms for those. But those are still a ways off, right? We have a lot of work to do to actually figure out what's going to work and what isn't going to work before we can take all of that and really materialize it in better practices.
Thank you.
Actually had one. So building on what you were just saying, what you were saying before, if you don't get the same answer each time, or potentially don't get the same answer, our typical SDLC cycle where I started off today with my presentation is let's try to get it right up front as much as we can, right? And then what we don't catch up here, we catch in productions. Well,
Yes.
if you're getting a different answer, right, when you're testing, right, doesn't that flip that whole paradigm? It looks like you're very much dependent on the production side to figure out what's going on and logs and so forth, and not the other controls that we typically have in the SDLC.
Yes, absolutely. And that's what scares me about this, because it's not even that what you're delivering is non-deterministic. It's that the whole supply chain that you're depending on now also has those non-deterministic qualities. So yes, that's I mean, I don't know of any other way to approach that problem other than actually monitoring all the inputs and outputs, and then having policies to look for the outputs that are harmful, and essentially training up the system on that side of things. But again, that's an imagination problem. That's not a traditional SDLC problem.
Now, the assumption here is that companies will be using this, right? Can companies say, no, it's too risky? What happened?
Sure.
I mean, you know, it's kind of like you're a bank. We've got regulations. We can't have agents out there just kind of deciding what they want to do on their own.
Sure. But we see where the investment's going, right? I mean, I'm sure there are companies out there today that are saying, we're still investing in people. We're still hiring a lot more engineers. Right? But the market trend is let's empower more of the machine systems to be able to take on these roles. And I'm an optimist in this. Like I'm a software guy myself. I love building software, and I love building new kinds of software. I think the answer here is just that we can't forget about the governance portion of that. We can't forget about the oversight part of that. The same way that if I hired a new engineer, I probably want to be paying attention to what they're doing, right? It's really the same thing here.
Other questions? You've got a question here.
Ooh. So there's a question from online. Could agents be designed to require onboarding, offboarding permissions at initialization? Should more security be built into the infrastructure, or does this remain a problem for security organizations? Yes, I'm such a huge fan of that, right? Security should, as much as possible, be represented through every phase of the development process, right? And I know that sometimes that rubs developers the wrong way when you say that, because that just what they hear is, oh, I have to do more work. But the idea that you can just apply security at the very end of the process, right? I mean, we all know how well that works, right? It's better to have the security built in from the beginning. I think one of the examples that you see to support that is you look at the current vendor marketplace, for example. 2-3 years ago, there were 10 notable standalone API security companies. And how many of those are left now? 1, maybe? What we're seeing is API security has been absorbed by the traditional security apparatus, right? It's not going to be a discipline unto itself. And I think that's the right thing. I think that's the right answer. It shouldn't be a discipline unto itself. It should be part of the normal practice. I think agentic AI and NHIs is the same kind of thing. It's a sea change. And I think initially you're going to see a lot of folks looking at this as a new discipline and thinking maybe this requires completely new ways of thinking. But I think the more you peel that onion back, the more you start to realize, no, this is just another variation of the kinds of security concerns that we already had. And so let's fit that into our existing tooling and our existing workflows.
Another question here.
Yeah, I thought it was very interesting. You were talking about like the imagination problem of seeing these new technologies and trying to fit them in a way that just makes sense. It seems like that's going to be a really big barrier for us to build security into agents or anything, any system that is using AI. Do you see that as the biggest barrier, or are you seeing other barriers as bigger to adopting these secure practices in these new paradigms and new architectures?
Well, I think the way to answer that is, when I think about this as a practitioner, the fact that I might not get the same answer every time, and that the answer may not be as high quality every time, like that bothers me on an academic keel, right? But I think when you look at that from a business perspective, well, a lot of businesses are built on assets that are semi-reliable, right? Including the humans that work there. And that's okay. So I think from a business perspective, if I get the wrong answer 1 time out of 10, I can probably live with that, because I probably would have gotten that from my human-based organization the same way, right? I'm facing the same kind of risk. I think the reaction needs to be that, normally I'm going to be monitoring my semi-reliable assets in order to find out. I'm going to have ways of auditing that. I'm going to have checks and balances within the organization to make sure that I'm at least moving things in the right direction, or things aren't going south without me knowing about it. I think from a business perspective, that's what we're going to see. The fact that these things are not 100% reliable, it's not a reason to throw out the baby with the bathwater, right? Because all these businesses are built on reliability issues in the end. I think the risk from the security perspective is over endowing the AIs without the proper oversight. And what bothers me about that is a lot of these API-based systems, they're fundamentally dark, and they're not audited, right? It's not like the old days where everything was website based and everybody in the company could go to the website and fill out the order form and did I get the right email back and all that kind of stuff. And that was really awesome, because literally anyone in the company from the CEO on down would be able to do that, right? But when we're talking about APIs, when we're talking about agentic systems, we're talking about systems that are owned by development. There's a lot of gatekeeping. They're dark. You can't just point your web browser at it and figure out what's out there, right? So we need to solve for that observability and auditing gap. Again, just to get back to a comfortable place where we know that those are mostly reliable, and we're able to dial in the risk from the organization.
Yeah, that's cool. So it sounds like we have the paradigm, but we need to start fitting this new approach of using AI into it so that we can use it effectively.
I believe that's 100% true.
Great. Well, let's hear it for Rob. Wow, very intriguing conversation. Wow. This is what I was hoping for. Is to start talking about this stuff and seeing where it's going. And now I'm scared, though. I'm very scared.
All progress is
scary. So
scary.
if that was your intent, we're going to do so. Thank you so much, Rob.
Thank you.
All right.
John Dixon, let's take it away.
Okay. All right. I'm John Dixon. I'm CEO of ByteWhisper Security. We have been, let me just tell the story, since I have about 2 hours here with y'all. Number one, been involved with OWASP since 2005, and was there in the first sets of meetings. I've been active for about, I guess, 20 years. Was a principal at Denham Group, and we had sponsored the chapter for about 15 years, I think, before Michael Shin and crew took it from there. So I've been a hardcore AppSec guy for a very long time. Much to my chagrin at times, I would say. And I'll just tell you this. I've said this over and over and over with this company. This feels a lot like 2004, 2005 with AppSec. I was in those meetings, and I can say this, where development managers said, that's interesting, injection flaw. That's interesting. Cross-site scripting error. Don't care. We're not going to do that. Or really interesting. We have deadlines. We've promised the business the code is due in 2 weeks. Thank you very much. Maybe next year we'll talk about application security or whatever the heck it is you're talking about. So I was there 20 years ago when we started making these pitches and creating the OWASP, and it was a thing, the top 10 OWASP for web applications, which seems ancient. And now it's like the same conversation. Instead of dev managers, it's data scientists. It's the same conversation. And if I didn't think this was the case, I had a cool conversation with a CISO from a AI security company that does product. And I said, hey, we're going to RSA, we're going to Black Hat, we're going to FSISec, we're going to all the security conferences. What AI conferences do you go to? Does your company go to? And I won't name the company, but she said, we don't go to any of them because the data scientists do not care. So here we go again. Why are we doing this? Because the data scientists do not care. We're having the same challenges that we did before, which is selling. So been at this for a while, and have worked with a lot of people in this room, and look forward to working with everybody else at some point. So I'm doing an AI panel at RSA in 3 weeks with a guy named Anton Chubakin, who's you haven't heard of him, kind of a smart guy at Google. I'm the least smart person on the panel, but this is what it's supposed to do, is to tackle this. And I'm going to just let you know, we don't know the answers. Like the questions that in our calls are like, is this something a CASB can just do? Like right mouse click CASB, DLP, maybe? Well, if you listen to the CASB vendors or the DLP vendors or the web gateway vendors, that's a checkbox, right? Is it that simple? Maybe, maybe not. By the way, I think that about the number that we counted is like 65 to 70% of the presentations at RSA this year have some aspect or component of AI in them. And for the record, in 2019, I did what's called a peer-to-peer session at RSA on how to vet vendor claims on AI. 2019. AI in 2019 was really ML. And this is before November 2022, ChatGPT, OpenAI, and all that. So it was like early stage, and the same problems existed, and the same set of crazy claims. So part of this problem that we have right here is the fact that, like, not just vendors, but everyone's going nuts over AI. So one of the reasons that shadow AI is out there is because you have every CEO that goes to every Gartner conference or every Harvard Business Review article or everything is saying, you got to have an AI play. So CEOs, executives, and then there's this chasm. Sometimes you have people below that can implement it. Sometimes you have a CIO that's pretty innovative, but the likelihood is you have the business VPs that don't understand it. So what is shadow AI? Shadow AI is a good thing. You're not going to believe this. What's worse than shadow AI? No shadow AI. That means you have an entire workforce that's not doing anything, like at all, right? Not downloading models from Hugging Face, not trying to create something. I mean, like all of it, right? So this is, I'm about to put out an article about this. Like, hey, before we like go down the path of passive judgment and all these people that are doing it, like it's a function of people trying to do the right thing. I'm not going to say innovate because that's an overused word. Makes me kind of throw up in my mouth when I say innovation. So I'm going to say it's people. I'm not going to use the word proactive. That's not my. I'm going to say these are folks that are trying to figure out what the CEO is saying, the business units, reading and hearing all this, trying to figure out where their organization should be, where they should be themselves, betterment. And the truth is that they have to learn this. So they're learning it, and they're doing it on the customer, on the client site, and sometimes that's good and bad, right? So that's the thing to remember. So here's some advantages of shadow AI. You're innovating, you're doing whatever, you're going fast, you're going real quickly, you're doing experimentation, you're downloading stuff from Hugging Face, you're doing things, you're putting it, but there's a downside. You're facilitating and getting smart on this. Here's the other thing that I would throw in there. You're starting to work with the businesses to have developed use cases and business cases for it. That's what I see as one of the biggest gaps out in the industry right now is what's the business use case of AI? You have all these vendors coming to you that are like, hey, we got this. I mean, the consumption of Copilot, the consumption of Microsoft Azure chatbot is most certainly driven by the Microsoft themselves introducing it to their clients, right? I mean, this is not, I mean, it's a good thing. I would say that's not a bad thing. But like a lot of this is vendors going to enterprise buyers saying like, you got to put this, here's our newest, latest, coolest chat. You know, the implementation of chatbots went like this. I mean, there's where like it got introduced and boom, it took off. But it's also not for free. So this allows you to compete. The joke in AI is businesses with AI are going to beat businesses without AI. That's kind of already a cliche that's out there. I believe it to be true. I'm also an AI optimist, and I do believe that having used it for really since November 2022 from a LLM standpoint, that there are things that you can use it for to really make as a business practice. How many people use a Zoom AI companion for meeting records? Okay, right? Or Copilot for Teams. Okay, raise your hands again. And this is a technologist group. How many of y'all are precluded from doing that? Okay, interesting. What is that? Optiv? Okay, just calling out Optiv there. Sorry. Yeah, that's Optiv on the bleeding edge. Sorry. That was. No, but the funny story is a lot of state agencies are precluded from using it because they're worried about discovery. Like you said, there's a lawsuit. It's subject to Open Records Act. So now you have an entire agency that's afraid of using AI. I think that's a bad thing. And when I work with these organizations, public sector specifically, I have to go to the executive directors or CEOs and say, you need to set the tone and make sure that this is a good thing. And I'll give you an example. And it's usually, I'm stuck on this slide, but I'll say the creative and positive use case development of business cases really helps you as security people. What I mean by that? What I mean by that is suddenly you're helping IT who's helping the business, but you're helping them to do it with guardrails and to do it in a way that 3 years from now you don't recreate problems that you had with AppSec. So this is the advantage is you're doing stuff. You're trying to compete. You're trying to get ahead. And how many people have seen the GitLab and GitHub and all the different like stats about code efficiency, coding improvement? The numbers are like 65 to 80%, right? It's phenomenal. Like you have to do that if you are a dev manager. But part of the reason Byte Whisper exists is because we get a sense that all these people are doing this, and oh, by the way, yeah, guardrails. That's an after effect. This is the same behaviors and instincts that we had with AppSec. They created OWASP. They created our whole industry that didn't exist 20 years ago is because dev managers were going a million miles an hour, throwing functional capabilities on the web, and then somebody said, wait a second. and again, thank you for doing that. It created Denim Group and now Byte Whisper. So keep doing that, whoever's doing that out there. Okay, here's the risks that are associated with, it's slightly different than Shadow IT. The only thing that they share together is the name Shadow and an abbreviation. But for the most part, you are downloading models. You're downloading models that you can train on data. So there's a ginormous DLP problem here, right? You can also, if you, like everybody knows this, and I'm assuming everybody's already heard this, that not only can you take software created by Copilots and ChatGPT, but you can hit their API and then come back. And you nailed it. The term was non-determinism. That's what I was saying, non-determinism. So the real problem with LLM created code is you put in the prompt, you get a response. You put in the exact same response, same prompt, different response. That's great, except it blows up our compute model. And the entire compute model is if statements that are predictable. And now you throw in this human, this roulette wheel this wild card, and that's the crazy thing. And if you hit an API and it's a business critical system or making consequential decisions around, like, I don't know, keeping the lights on, keeping the bank going. I'm a Frost Bank client. Yeah, don't do that, right? I mean, like, if I got to take my money out, actually, I mostly put my money in. But when I have to,
here's an example, John, that I'm worried about. What's my balance? What's 15,000 next time? Well, no, it's really 22,000.
Yeah.
Oh, wait a minute, it's 10,000.
so that and not
work?
that and that's luckily that doesn't really happen that way. But this idea of the variable, the non-determinism, whatever you want to call it, that is mind-blowing for a compute model that's existed for, I don't know, 60, 70 years, which is if statements, business logic. And, you know, if you change the business logic, then you have to go back and test and do all this stuff. But like, this is crazy. So automatically you're not in compliance. I will just point out, if you're GDPR, like here's one thing that I could just say, as somebody in the trenches talking to people all over the place on this issue, there are no laws to which we have to follow for AI right now. Think about that for a second. There is not a national law on AI, unless you're in Europe. There's not a national law. There's not a state law. There's an HB 8 that's proposed by Representative Capiglione from Flower Mound that may or may not make it through this session in Austin. But there are no state laws. There are no national laws on AI. Guess what there is? There are privacy laws, and there's a history of privacy. Well, guess what? What are you sitting on? What are you training your models on? On data. So that's what we see everybody doing, is like essentially leveraging and looking at their data security mandates or data security laws, whatever sector they're in. Because, and we've seen this in policies. Like, hey, look at our policy. The first statement is, we will follow all national and state laws. There aren't any for AI. Our industry, what industry? Nope, aren't any at all. Nope, not at all. There's and by the way, the NIST AI risk framework is not a law. It came from NIST, and oh, by the way, if you cite the EO, there's going to be a new EO, and my suspicion is the new presidential executive order is going to look slightly different than the last one. That's my prediction. So, because of like this explainability issue, the randomness, you know, auditing. How do you audit? How do you like your auditors? Sorry, auditors, you're not going to ever know about this. Outputs might be biased. Ooh, you just introduced biases. They're real, particularly in things. And I had this discussion about a year ago. True story. For those of you from San Antonio, most of you, there was an initiative that came out from an organization downtown to put cameras in and leverage the cameras to monitor and use it for identification. So if you don't know what a slippery slope looks like, that is what a slippery slope is. And what happened is they said, oh, we got all this downtown crime. There had been a shooting at Fiesta. If you remember correctly, last year there were 2 downtown shootings. People died. There was a perception by business owners that there's an issue with public safety. Let's leverage all these cameras. Police chief said, this is great. You know, we might even be able to find people that have an open warrant out, and we can just arrest them. In a moment of candor, our police chief and some of our senior elected officials voiced what everyone doesn't want to happen, which is you're walking down the street and Brent Doherty, I guarantee there's a bad guy in San Antonio that looks just like you. And you're gonna be walking down the street and suddenly you get thrown in the car because some machine learning algorithm and facial recognition software that was imperfect made you look like that bad guy. So this stuff is real. Biases is real. If you're familiar, there's a Rite Aid, which is kind of like a CVS or Walgreens competitor. Rite Aid had a lawsuit on this. They put in a camera system to prevent what they call shrinkage, i.e. shoplifting. Guess what it did? It inordinately flagged African Americans and also Hispanic people. Can't do that. Can't do that at all. So this is real. So if you have people downloading stuff from Hugging Face and starting to train it on your data, suddenly you might be out of compliance, and that's not even a word, more realistically, you are at legal risk. Rite Aid got sued for that, as they should have been. But was it Rite Aid doing an AI project internal? No. They had it as a vendor. They subcontracted it to a vendor. And guess what? How many vendors do you think that are doing surveillance and camera monitoring have no ML background? I mean, seriously, this many. Zero. They all have it now. Or if they don't, they're going to go out of business. So but it's not the problem, the fact that they have it. That's pretty cool that they have it. But they took out the human in the loop component to it, and they went from identification to arrest. That's the problem. And that's where these things really become, So the key here for y'all is to figure it out and identify it before it happens. Or while it's happening, probably is more realistic. And you can do this. And it's not just going to Force Point or going to, whatever vendor you have and saying, go do this. That's part of it, or a little bit of it. But you want to try to minimize this, at least be aware of it, right? That's the starting point. So it's easy to say, right? You want to manage it. You don't want to do what AppSec did, which has become, it took us like 4 or 5 years. And again, I'm looking at Michael Shen because Michael and a lot of us were there when we looked up and it became real when we already had 2 million lines of code out there. There's so much legacy code that you weren't going to fix it with source code reviews. It was just like, oh, well, then there was like, oh, put a WAF in front of it. Remember those discussions? Put a WAF. Okay, yeah. We're going to find the most obvious vulnerabilities that your scanner could already find, and now we'll manage those. But all the architectural flaws that you'll never find, you still won't solve those problems. So it's the same issue here, right? So, okay. So the good news is, I got good news. I scared the poop out of everybody, which is what I do for a profession mostly. The good news is it's very noisy. I mean, like the likelihood that you're going to do shadow AI and there's not going to be some signature or there's not going to be some type of footprint, it's noisy. I use that term. I'm a former intrusion detection guy, IDS. So I like the term noisy. But it's going to have a footprint, whatever you want to call it. So network traffic, right? These things have to talk something. Now, what port? Anybody's guess. That's where you're going to have to look and start to understand what your profiles are on your DLP, or maybe your CASB, or your web gateway, or your firewall, or some combination, depending on what vendors you have and what mix. A little bit of everything, right? So it's going to show up in different places. My strong opinion is now, at least until there's a market consolidation, as we're talking about, I totally agree on the API stuff. Like there's going to be a market consolidation here, but until it's one size fits all, these things are going to show up in different places. And by the way, if you're big enough, you're going to have teams, you're going to have technologies, and none the twain shall meet. They won't talk, right? So don't assume that the endpoint detection teams is talking to the web gateway people. Just don't assume that. I've experienced that over and over. Email visibility. You had to sign up somewhere, right? You had to sign up somewhere. So like the simple act of scanning O365 inboxes, it's actually meaningful here because there's not 6,000 like open AIs. There's a bunch, but I think you can find this stuff out pretty quickly. There are products that do this now for the record. Endpoint scanning, so also good old-fashioned like vuln scanning to find out where endpoints are. That's also part of it. And the other part is policies. Now this is funny. It's interesting. I'm not a big fan of policies, except when clients pay me to work on policies. Sorry, that was an inside voice. Except when you're like early stage, like InfoSec policies. I'm old enough to say that I wrote InfoSec policies in the 90s when there weren't any, but now this is so brand new that like, okay, you can go with ChatGPT or not and go crap out a pretty decent AI policy and at least put your folks on notice that this is something that you should. And really what you're trying to do is set the tone, but just say, hey, look, we want to use AI, but we're putting together this architecture review board. If you're doing this, at least just self-identify and say, hey, because we want you to be able to use it. What's happening now is the initiative and then the business unit imperatives. Those two things, the individual initiative, business unit imperatives are starting to have this crop up. That's why you want to have a good policy, is to get in front and provide clarity. You can't, like, I think telling your users that you can't use AI companion for conference calls is super dumb. Now, for the record, AI companion has hallucinations. In my call with our outside counsel one time when we first got started, in the bottom I read it and it's like it said, "Oh, John Dixon commits to 100 million or like 100 million in legal fees with law firm." And 20, I was like, I didn't say that. They pointed out that like they agreed with that statement. It was an obvious hallucination because I'm CEO. I want to pay the bare minimum for legal fees, but it was pretty funny. But what I do know is that particular technology does an exceptional job of capturing the next steps. So I may not use it as an official transcript of our conversation, but when I like set up a call with Adrian and like 2 weeks later we have another call, I can go back and say, "Oh, I promised Adrian I'd send him this. I forgot to do that." That's, as a memory prompt, fantastic. It does. I mean, and I use it all the time when I can. And so much so that when I have a one-on-one conversation, or I use Teams where they don't do it, I'm like, "Oh crap, I got to take notes. Damn it, man." You know who it's worse than AI companion for Zoom is my notes, right? Okay, so policies are good. The other thing I would just say about policies, focus on two things. Consequentiality, that's a big word. What that means is like, what are the apps that matter? Don't worry about Grammarly or whatever the hell, all these like SaaS platforms. I mean, those are important, yes. But really what you're worried about is those things that hit your production systems. Oh, if you have a vendor that's doing this, that's going to touch that and use that, okay. We probably do need to have a little risk discussion and do I don't know, maybe a threat model. Remember the old threat modeling? So maybe we should have that. So the consequentiality or the importance, criticality of the apps or systems, software, SaaS, whatever. But the other thing is who. Now, I would make an argument right now, and it's not widely thought of. I'll probably talk about it at RSA. Don't really care what all the users do. Kind of do, but not really that much. Don't really care what the execs do. They'll damn it. They'll do their own, wreak their own havoc on their own stuff. What I'm really worried about are the dev leads, the architects, the people that have the business interest and the wherewithal to go download Hugging Face, make sense of it, and start doing this. So one of the things we preach is like, hey, spend more time with those people, get them so they can make risk decisions. Oh, by the way, who are the people that are most likely to be on the architecture review boards? It's probably those folks. They're the ones that are going to be taking they're going to be getting the applications for new LLM technology. They have to make the consequential decisions, whatever. So spend a lot more time. What that plays out to, from a practicality standpoint, is everybody else, all your desktop users, have them do the CBT, or whatever, e-learning, whatever you want to call it. But for your architects and your security leads, your dev managers, your tech fellows, have them do like an actual class with a smart person who's been in OWASP for more than, 2 years, and have them like, okay, let's look at the OWASP top 10 for LLMs. Let's walk through a use case for each one of those. I mean, I swear to God, if people did threat modeling, even 5 minutes and a whiteboard with that would save so much heartache. I mean, I would say of the 20 years in this business, the worst apps we've ever looked at were ones that weren't coding flaws, there weren't execution flaws. They were like, somebody trusted this input from this API, and you're like, wow. The one that I'll give you a great story, war story, true story, and it's long time ago, so I don't think we have anybody here. We did an assessment, pen test, whatever you want to call it, for a company that did work for banks. And the use case was you would go into a bank teller would order it. And so they had like an enterprise app that would go talk, you could order it, and they would send it to the bank location and the bank branch, and then the client would go pick it up, whatever it is. So what did they use? And so we're doing this pen test. It was like, okay, so again, use case is bank talking to third-party provider, business to business, APIs, calls, all these calls. And one of our pen testers noticed that there's this 9-digit number flying around, all these 9-digit numbers. It's like, what the heck? And this is, using a web proxy, just like, and something that a scanner would never pick up, right? An automated scanner. It's just like looking at this stuff, like we Googled it. or excuse me, at that time probably we asked Jeeves or whatever it was, or Alta Vista or whatever. But like, oh, that's the transaction routing number for Wells Fargo. That's the transaction routing number for Navy Federal Credit Union. That's the transaction routing number for, like, you name it, bank. So what this company had done is used as a form of authentication. The first form, the username, was the originating bank request. And they just did a one-up numbering for the password, temp password, which you'd be happy to hear was easily guessable. And with a script that was like this long, you could recreate the numbers. So we did that. So we couldn't order as a new person come in, but we could go hijack other accounts and then order it and send it to us and change the address. So it was it was such a good find that we had to do a second pen test to the executives who didn't believe it in live. And I had to coach our pen testers, have a poker face, have a poker face, have a poker face. When you do this, and you do this in front of them, don't laugh and don't high five. So it's kind of fun. Those are fun. So anyhow, policies are important. So you want to do this. You want. Here's some other ways to do this. Other ways to detect APIs. I mentioned APIs as an example. Monitor endpoints. Utilize behavior analysis for those that are doing really actual behavioral analysis. You can find it there, and then start. I mean, like the way that I would do it is to, as an outside vendor or as an inside project, is to do it small, a test case, and then go from there and find out. Say, hey, we're going to tackle and look at our network management and see if there are any indications of these things. What else? As I mentioned, policies, provide, like communicate. This is an important one, the bidirectional communications. We see that problem all the time. Like, hey, if you're looking at this, call so-and-so, AI at so-and-so, because there might be one that, because here's the other thing. Are we going to use this from Microsoft? We're going to use this from OpenAI. We're going to use this from Anthropic. Like there may be one that they've already executed a corporate agreement with, right? So there's that too component. But the key is rogue or innovation is bad. So that's me. That's how to get a hold of me. And I just want to tell one last story about our industry and my name. So how many people on the sales side? Okay, you just admitted it. Like that's pretty cool. It's the first step to recovery is so I've been in business for a very, very long time. And after we sold Denim Group, like about a year into it, I started getting all these phone calls on my cell from all over the planet. And they're what I call sales development reps. So these are like people that are just smiling and dialing, calling to get a phone. Like, why are you calling me? I noticed that there's like over and over. I finally talked to a guy and said, look, I am a vendor too. I've been a vendor. Like, why? Oh, you're not the CISO at Colonial Pipeline. So if you Google the CISO for Colonial Pipeline, who I know, oh, sure enough, the other John Dixon, spelled the same way, he, some sales rep put my mobile number into his record in Zoom Info, which is like the universal sales guide database. So I learned the magical thing in iPhone to say only from my contacts. So I can't have an open phone anymore because I get calls. Now you'll be happy to hear I don't yell at these people or scream. I just say, hey, I'm a vendor too. Here's a good book and I give one or two sales books, and take me off your list. But I still get them. So I'm not snarky. I'm not snarky to them. I say, hey, FYI. But like John Dixon and I think I'm going to try to connect with him at RSA. But like I still get those calls. He's like, dude, I'm sorry. I get them too. So there you go. With that, I think we have time for questions and answers, hopefully. Or maybe not. I'm okay with that too.
I have one.
Okay.
So we're talking about policies before. Before you came in, we had a presentation on agentic AI, right?
Yeah.
Kind of advantages and disadvantages for that. When we're talking about policies, could you have AI agents ingest those policies and help enforce those policies, and actually have AI agents that are kind of enforcing watching the other AI agents on the network and making sure they behave as appropriate?
I don't know if y'all have touched on RAG, retrieval augmented generation. Okay, right. Okay. So yeah, that's the starting point is like, here's our truthiness, here's our truth. And using a well agreed upon policy that like knowing what you're training on and knowing what you're using for RAG is the starting point. The problem with like agents in general, I think agents are cool. This idea where like an agent can talk to another agent and set things up and medical appointments and magically shine my shoes or do whatever. Like, hey, I'm all in. But we got a long way to go. What I do see in 2025 is the like almost forced rollout of these because vendors are saying, hey, we got this. And there's not any abuse case thought. There's no testing. There's no guardrails. I mean, like, and can you test? You better believe you can test these. How do you test against it? I do. Our CTO wrote a really good blog post if you're interested about this. It's so detailed that I understand about 50% of it. But like the truth is, the key thought here is you should do some form of abuse case testing and understand what you're training your data on and know like some thought. And I think most of the people that we're dealing with, mid-market, small enterprise and above, a lot of them are not doing it. Now, the biggest banks, no offense, the big tech people are doing this. It's the regional banks, it's the Fortune 5000. They're like, hey, we rolled out an agent. Okay, cool. So the Air Canada case is probably one that y'all have heard of. If you haven't heard about it, it's one where the Air Canada chatbot quoted some flight data or flight costs, and then they came back and said, no, we don't honor that. That's just our chatbot. And a court of law, I think in Canada, said, yeah, you're held accountable to that. So that's the industry perception now is whatever your chatbot says, you're on the hook for. So that's the other thing is you got to make sure that you're like, it's not going out there. So that's where the abuse case testing goes. So again, haven't done, or I say not done, managed or been near pen testing for a very long time. We did at Dinner Group a tremendous amount of testing for consoles or for functions on host in cloud environments. There's no tool set for that, right? So the truth is the testing for this is like 90% whiteboarding and developing that. What was that called? That modeling, modeling, and then probably 10% technical testing, or maybe not technical testing at all. You're not worried about breaking out of that instance. It's more like, can you get the agent to cough up more information that they're supposed to, or say things they're not supposed to? What did you say earlier? You said something that's lack of creativity. What was your quote? I love it. Say that again. Failure of imagination. Okay, I'm going to write that. I love that. It's a failure of imagination. And when you're doing testing of these type of things, you need people that can think in a break mentality and not a build mentality. And that if you go to the most companies, they just don't exist. They exist here. They exist in pockets, but they don't exist. Again, I've been in millions of these meetings where dev managers are like, well, why would you do that? Well, wait a second. The RFC says you can't do that. But the attack community is not constrained by the RFCs or any technical standards. It's like that's the point. So, yeah.
Other questions for John?
Yeah.
Go ahead, Michael. You need a mic? Yeah.
Michael, you go first.
We got a mic?
Mic for Mike. Roger that.
There you go. Mic for Mike.
Yeah. I don't know if they can hear us online. So, John, quick question for you. So, the whole concept of shadow ID, AI, the unauthorized use of tools, you guys talked about kind of manual detection of it. Like, what I've heard, it's pretty cost prohibitive to kind of, everybody downloads ChatGPT and it's like free or it's $7 a month or whatever. But we've seen organizations where if you go through like Microsoft Copilot, it's a substantial investment. It's kind of like the old client server. And then it's a substantial footprint per month. So, I mean, do you see the adoption, skyrocketing or just kind of leveling off because it may be cost prohibitive to bring in tools like this?
Okay, so let me, Brian Mather asked, like, what's the cost of adopting tools? So, like, again, I think the number is $30 per head per cow for Copilot. Correct me if I'm wrong. 30 bucks. I mean, Microsoft is not giving this away out of altruistic purposes, right? And I think the other thing is too, and we've heard this from clients, so this is hearsay. This is not fact. But $30 per user per month on top of their user license. and their EA might go up from a level 4 or 5 to level 3. So these impacts. So here's the deal. Like if you're IT people, your CIO is gonna spend hundreds of thousands of dollars more, or maybe millions of dollars more for your like baseline Microsoft license, enterprise license. You should do some technical testing and some threat modeling and some policy. I mean, this is back to OWASP 101. Like you're pushing functions and features out to the platform and you're not thinking about it. Like, come on. So I think again, I've been, Google my name in OWASP and you'll see presentations back to 2012 and 2011. I've been preaching about this forever. It's the least consumed discipline of all is AppSec. Think about that for a second. I truly believe that, because most CISOs or network security people are, oh, we got to have a firewall, got to have access control. You can actually push out apps to the App Store or online without testing them. Happens all the time, right? So like our job, ironically, is a sales job, ironically. Even though we self-identify as technologists, we're really selling the business to actually do it or do more of it. Same thing here, exact same thing here. So they're spending hundreds of thousands and millions for a license, but they're not doing some of this stuff. Same.
I think we had a question over here. Is that right?
Yeah, sure.
Mike?
Yeah, John, thank you very much for the talk. Also, thank you for many years of support of this chapter. Really appreciate. So I have a question. One of the main reasons I observed for the shadow AI is because the security is moving too slow. If the new technology came up, the first response is block it.
Yeah.
So, and cybersecurity generally understaffed, and there's so many things that we need to deal with, vulnerability management, all of that stuff. So, because it's happening almost everywhere.
Yes. How do you do it? No, I'm being facetious. Michael, Shin, and I are friends. I mean, this is the start. The start is you recognize it's a thing. If you go back 2 years ago, this didn't exist. I mean, this is the first time I think it, I mean, like real substantive discussions around it. I would say, like November 2022, that was 2.5 years ago. I mean, a lot of this stuff has happened since then. And I would say the first thing is to have a discussion and start, put it on your work, your program of work for 2025 or on your list of things you're doing. Hey, we're gonna at least have a discussion with Shadow AI. The ally for this discussion is legal. Because legal, like I think that if you can co-opt legal people and have them be the protagonist or the leader and pay for it, even better. Hey, yeah, I hate Shadow AT. It's all over the place. And then get them to pay for it. But I think it has to start with the organization realizing it's a thing. And I don't think everybody is. I mean, part of the reason I didn't retire is because I think this is such a big deal here. And I see people recreating the same behaviors. I'm like, oh my gosh. And I think that's absolutely the case. So that's not a great answer. Have a trusted vendor come in and do it, whatever way you want to do it. But like, it ain't gonna get better. Like the policies, the review board, the Shadow AI, it's not going to improve. It's so if you have a chance, maybe this is 2002, 2003, before the notice line, you might be able to influence behaviors. You might. So.
More questions? Any online questions? Do we have any online questions? We do?
Okay. Hopefully they're appropriate.
Yes. So we have a long question here.
I'm wearing a jacket. What are you wearing? I'm wearing a jacket.
Yes. If things go the same way as earlier technology sea changes you reference, then what does this mean for jobs and contracts? Will we see no market for AI security until problems are very prevalent? When will this become a priority for platforms vendors like Microsoft?
Well, I mean, it already is a priority for Microsoft. They invested in OpenAI. They have Copilot. They're doing a lot. I would argue the harder thing is everybody that's been doing their own thing for 20 years in app sector and security. How do you up-level your skills to become an AI smart app sector person, AI smart SOC analyst, AI smart whatever? That's the bigger problem. Like I can promise you, every company out there that's on the vendor side is throwing every bit of resources that an AI does. There's not a CIO out there, CEO out there for a technology company that's like saying, no, we're not doing this. It's the opposite. So the technology product and service company, service world is going all at it. As a matter of fact, if you go to any of these like pitch meetings, like venture capital pitch meetings in Austin or San Antonio, different places, if your company isn't whatever .ai, you don't have an AI play, you're like, what? I mean, the bigger issue is like the vast unwashed masses of security people that have been kind of plunking along for 20 years. What are they going to do to understand this stuff and be able to manage it? So there's no great answer there. I would just, my private experience is most of the academic stuff is dated. So if you say, well, I'm gonna go start taking a night class at UTSA or whatever, I'm sure they're great ones, but most of it is somewhat dated. It's a function of these type of things, self-learning. I like, Udemy has a bunch of stuff out there. There's like a really good set of IBM little videos on YouTube. They're like 7 minutes each. That like if you knew that, nothing else, but they explain like RAG, they explain all these different things. Like if you can just know all that, you'd be halfway there. So I mean, I learned it. I mean, I'm a political science major, so if I can learn it, I can go that.
Mm-hmm.
So.
Other questions?
Okay.
I remember 2005 or 2012, people were talking about the cloud journey and the very suspicious of it.
Yeah.
CEO, CIO, no one really believed it was real, that they could trust it, they could do anything with it. And even now, 15 years later, there's still companies out there that haven't really moved really strongly into a cloud platform or a cloud posture. But with AI, it's like no holes barred, man. Everyone's just going crazy with it. It's nobody's stopping, nobody's going off ramps, nobody's installing speed bumps. They're just going crazy with it. So why the difference between cloud and AI?
Well, I think first of all, cloud. I mean, there was a compute model that existed from the early '90s till like 2005 to 2010. So you had established data centers, you had desktop apps. I mean, it was a known. And I remember seeing old like PowerPoint pitches of like, here's our network, and there was like a wagon train around it. Like here's the inside, here's the trusted network, and here's the outside. And then that started to fall apart with remote access and in the cloud. So I think there was a sense that the unknown and that the existing model, which was data center on-prem, was problem solved. Right now we're going to something else. Back then I would flip it around and say, like, are you going to trust your on-prem AD person and your one security guy versus all of Microsoft or Google or and so that problem got solved over time, I think. But you're right, it's not completely solved, and there's now use cases where people are bringing it back in. AI is a different beast because there is a sense that it is changing the compute model in an even bigger way, and there's an efficiency component. There's a cost savings component for cloud, which is a CFO play. Like, I can take that on-prem stuff, all the data center, all the people turning wrenches, and just throw up in the cloud and save 50%. That was the original play, right? This play is like, I can do everything 50% faster. So that's the CFO play, the cloud. This is a CEO play, which is like, I can beat everybody in the market by going 50% faster. So I think that's part of it. I think it's also oversold. If you read a book called like the Brief History of AI, it's very dry, about halfway through it. But like the constant theme of this book is the overhyping and overpromising of AI. There's been an AI winner, 2 of them, I think, at least. And so that's part of the problem is the crazy hype. We're going to see it at RSA. Like every vendor. That's why I did one in 2019. How to vet vendor claims, because in 2019, vendors were already pitching AI, which was really ML. So it's like, here we go again. So that's part of the challenge, like the training part. How do you as buyers, particularly on the buyer side, determine and discriminate vendor claims? I'll give you one answer, by the way, from that panel. Two bits of answers, 3 that came out of that panel. One is, the question you ask vendors is, how is your model different than hard-coded rule sets? How? And if they can't explain, the product manager can't explain, say, let me talk to the engineering manager. But and the question was that I asked a bunch of vendors in 2019 was, how does your SaaS platform improve false positive detection, or not detection, the other way around? Because it's, all the SaaS platforms are worried about missing false negatives, so they, well, not check marks, but other ones, we get all these findings, and you go to your dev manager and say, hey, we're cool. We found 10,000. We ran a scan. We found 10,000 highs. You're cool with that, right? So my question to them in 2019 is, how do you cut down on false positives with your SaaS model? And the answers were, oh, that's proprietary. Oh, I don't know. It really was one that answered it well. And at the time, I won't tell you which one, but and then the other question in that panel was interesting was, show me your white paper. Like, what is your actual play? And at the time, nobody had white papers. They do now. But like, tell me your play and how it's different. And the third one is, that came out of that panel was data sets for proof of concepts, which is actually quite tricky now. Like, what are you going to train on? What are you going to do with that data? And is that data representative of everything else? So that is actually a problem that we still have, which is, if they have never encountered that, that's an indicator this is their first time they've ever done it. So that's what you want to avoid as a buyer, Joe, however the buyers are, is like this is their first time. Hey, show me. Oh, you don't have a white paper. Oh, tell me about what kind of data set you need. And if they don't even have that discussion down, that's their first rodeo. So, which even in Texas is bad. So.
Great. Mr. John Dixon, thank you so much. Thank you so much. All right, we're going to close this thing out. And then we're going to get some drinks, go to the patio. Oh, another prize. My goodness. I thought we were done.
Yeah, handed them out. Okay.
Yes, absolutely.
So getting from the OWASP headset. So that should be pretty nice for all you young guys, or guys that are babies.
Hey, drum roll.
Yeah.
5699. 223 5699.
All right.
All right.
Yeah, Chris. Thanks. All right, and then we all have the standard Apple AirPods. So that's going to be kind of nice.
We got a ticket.
Yeah, not yet.
All right. Mix those up.
Zach, one more chance.
223 5690. 5690.
223-5690.
5690.
Well, keep drawing then.
All right, here we go. 5720.
5720. All right. Hand that off to him. You want me to finish up? The slides ready to go?
All right.
Am I finishing up?
Okay. Who's presenting? Candidate topics. It's me. All right. All right, guys. This is where we talk about what's coming next, right? So we got a third quarter meeting going to be coming up in the September timeframe, and we always ask you guys, what do we want to hear about next? So here's some options just to get the discussion going. OWASP futures. We heard some things about OWASP today. There's a bunch of stuff with OWASP that they're working on. The LLM top 10, all kinds of new guidelines and things coming out. We could have a session just on everything that OWASP is doing. So that's one option. Another option is AppSec metrics. How do we measure success? Different ways of measuring success for AppSec. Maybe even leveraging AI to do that, as we're talking about today. So that's another option.
Microservices security. Well, everybody's kind of going to microservices and APIs now, so maybe that's another topic we can have a whole session on. Application security posture management solutions. Probably have vendors knocking on your door, right? You know, say, oh, ASPM, man. We have a session about the value of that and how to leverage that effectively. Women in AppSec. That could be pretty exciting. You know, what's going on there and who's in the industry there. Post-quantum cryptographic risks. Did you hear about quantum computing, you know?
John, what do you think about that?
Otra vez.
And then, of course, with that, you know, if you want to present, let us know too. If you have something you want to present on, we're always open to hear. So out of those things here, I'm just going to go down the line. OWASP futures. Can I see some hands? Got a few hands. Okay. AppSec metrics, measuring success. Okay, not really. This is why we do this. Microservices security. I got more hands coming up. I got more hands coming up. Application security posture management. About kind of an equal amount. Yeah. Women in AppSec. A few. Post-quantum cryptographic risks. Do we even know what that means? Okay, we've got quite a few there too. So it sounds like, which ones do we have?
Microservices or post-quantum?
Microservices and post-quantum came out on top. Do we agree on that?
I don't think everybody was ready for the first one. We need a redo.
A redo on OS futures. You can see a raise of hands on OS futures.
Zuri's over here too.
When is AppSec USA? Does anybody know when and where? AppSec USA.
AppSec USA. Add that to it.
When and where? Anybody knows?
No. I think it's that back. Not global AppSec. That's going to be in DC. That's going to be in DC.
We'll take this back into the board meeting and figure out which ones we can.
Yeah, it's not just one, but we can line some of these up. Any other suggestions that's not on here that people want to hear about? Let us know. Yeah.
Next,
Next one.
All right, so track is the board members responsible for this. We're actually growing by leaps and bounds. We're not, we were pretty excited about it. And just in the last 48 hours, we went from 390 meetup people in our group to 430. So we now have 430 people that have joined the chapter group. So we're pretty excited about that. We know we had some challenges with the audio today. For those online, we'll apologize. We're continuing to work on it. We'll get better at it. But I think outside of that, we're doing pretty good as far as the format, what we're doing, and the topics. I think we had a lot of engagement today from some of the speakers, so we're looking forward to continuing to do that. Next slide. Sponsors. Again, we want to bring your attention to the people that are sponsored today. The people that were speaking, which would be Graylog, and that would be Indoor and now Secure. They all supported this meeting and helped us pay for the lunches and all the prizes and things that we did. Also, as I said, Rapid7 and Sneak will be outside for a demo table. Sure would like to have your attention for that as well, because they also help kind of sponsor this meeting as well. For those of you that are online and for us, we're going to be, Aisha is going to be doing the attendance certificate, so you guys can get your CPEs. She'll be sending that to everybody. When you signed up, we asked for email addresses. If you didn't do that and you want a CPE certificate, please make sure you send us your email address as well from that. And I think that's everything for me. What's next? Here you go.
Okay. So tentative date for our next quarterly meeting is September 19th. It's always the third Friday of the month. We chose September because a lot of people traveling in the summer and so forth, so we thought that would be a good date. So now we're going to start the best part, networking and happy hour. You should have gotten 2 tickets for drinks. If you want to have more than that, you're on your own. All right? And again, as Brent mentioned, there's demo tables out there. You can have drink in here network. You can have a drink out there network. I think it's nice outside. I'm going to be outside. Thank you all for coming. Suggestions for improvements and everything, I'm here. You know, grab me. We always want to continuously improve and make this better. Thank you so much.